All right, so we are going to be moving on to our next topic, which is going to be biochemistry. Just to let you all know, this is a difficult concept. Some of these things we're going to be getting into, and what that means is it's going to require your time to do well on this section of our class. You're going to need to study your notes a little bit each night and let me know when you're getting stuck or confused. Okay, and what I mean by that is if we cover something on Monday, I would like to hear by Tuesday or Wednesday if you were confused about Monday's lesson. That means you have to be looking at your notes a little bit each night. If you let me know a week later that you were stuck, I will do my best to help you. But what we learn one day kind of snowballs into the next day, into the next, into the next. Okay, so the way to do well with this stuff is just to study your notes daily and let me know as soon as possible when you're getting confused. Okay, so we're starting off with the chemistry of water. So take a minute, write down that title. And as I go through this video, if I go too quickly, you all know, just hit the pause button so you have a chance to write down what I'm talking about. Okay, so we're talking about water. Now, not the water cycle, but about a water molecule. I think you all know this. If you don't know this, jot this down. But water is a molecule. Okay, it's made up of 2 hydrogen atoms and 1 oxygen atom. This is what we're going to be exploring in this video. Let's take a look at this. This should look familiar. I'm sure in middle school, maybe 7th or 8th grade, you looked at the periodic table just a little bit. So up top here we have oxygen. All right, and here we have something called the atomic number. What the atomic number is it tells you the number of protons. Okay, so here oxygen has 8 protons. And if you remember, protons have a positive charge, and they exist in the nucleus of the atom, which is that center part. Because oxygen does not have a charge to it, okay, and if it did, it'd be called an ion. But because it's an uncharged atom, it has the same number of electrons as it does protons. So that means it has 8 electrons, and those are negatively charged. Electrons orbit that nucleus. I'm going to talk about that in just a minute here. Down here we have the atomic mass. What the atomic mass is it's the number of protons and neutrons. Okay, those two subatomic particles have mass to them. So here we have 16, and if we subtract out those 8 protons that we have, it means we have 8 neutrons. Neutrons are uncharged, and neutrons and protons make up the nucleus, and electrons orbit that nucleus. Down here with hydrogen, it's a little bit different. Hydrogen has an atomic number of 1, so it has 1 proton. Okay? Because there's no pluses or minuses written around this, we know that it's an atom. It's not this thing called an ion. So it also has 1 negatively charged electron that orbits that nucleus. And if you look down here at the atomic mass, it's 1. Well, if we subtract out that 1 proton, we pretty much get 0. So what that means is there are no neutrons in a hydrogen atom, which is very strange because all the other elements have neutrons in their nucleus, but hydrogen doesn't. Okay, I don't think you need to write anything down from here. We'll get this written down in just a minute. But I just want to remind you about these atomic symbols and atomic numbers and atomic masses. You'll be doing a lot of this in your junior year in chemistry. Okay, so here's everything we just said. This is where you need to write some things down. I'm probably going to advance through this a little quickly. So again, please feel free to pause this until you get all of this noted down. Okay, this is everything that we had just said. Okay, so guys, I'm going to move on here. So pause this, get this written down, then hit play. And I want to draw a picture of a water molecule. So I'd give yourself maybe about half a sheet of paper. I'm going to put an O here. That's for oxygen. That's going to represent our nucleus. We have 8 protons in that nucleus. I'll put 8p positive. We also have 8 neutrons. Now we have 8 electrons. They orbit this nucleus. They orbit in these predetermined shells or orbitals. Okay? And so think about planets going around the sun. They go around in a set path. Planets don't just go around haphazardly. Okay? It's very predictable. The first orbital can only hold 2 electrons because it's just a smaller circumference here and it can only hold 2. Those 2 electrons get as far away from each other as possible because they're negatively charged and they repel one another. We have 6 more though, because 8 minus 2 is 6. The other 6 go into the second orbital shell. and try to draw them evenly spread out. That's pretty good, I think. All right. Now, I'm going to draw hydrogen off here to the side. Hydrogen has in its nucleus one proton, no neutrons, and has one electron orbiting. Now, atoms, or when they're together in things called compounds or molecules, the only reason why, I should say the main reason why chemical reactions occur is because atoms want their outermost electron shell filled with electrons. That's why chemical reactions occur. Not that they think about this, but this is the way that it happens. And let me show you what I mean here. With oxygen, the first shell can hold 2 electrons. So that one's full. That's good. The second orbital can hold 8. But guys, we only have 6 out there. That's a problem for oxygen. Oxygen wants its outermost electron shell filled. So it can acquire 2 more, and it would have 8 out there, and then it would be done reacting. Or it could get rid of those 6 and just have this first shell that has 2 in it. It's never going to get rid of those 6. The reason why it's not going to is because those 8 positive protons in the nucleus will hold on to those electrons more tightly if you start getting rid of some of them. So oxygen wants to get 2 more electrons. Look over here at hydrogen. It only has one of these electron shells, and that can hold 2. Hydrogen has, again, 2 options. It can either acquire another electron, or it can get rid of the one that it has. Hydrogen will do both. Okay, and we're going to see that during the year, that sometimes we see a hydrogen that's missing its electron, and it's just basically just a proton, and that has a role to play in cells. And sometimes it doesn't do that. Okay, so what is hydrogen and oxygen going to do here? Well, they're going to combine, and they combine in a very specific way. Hydrogen wants an extra one out here in its outermost shell, and oxygen needs an extra 2. So what hydrogen will do with its one proton is it will get so close that its electron shell with that electron, here's our nucleus here, it will overlap with oxygen's. Now, what does that do? Hydrogen now feels like it has 2 electrons. It has its own right here. And these of oxygen, as they're spinning around, they spend some time inside of hydrogen's orbital shell. So hydrogen feels like it has 2. And oxygen feels like it has 7 because this one of hydrogen spends some time right here next to oxygen. With atoms, sharing electrons is as good as having them yourself. Okay, so this arrangement is just fine. Sharing is as good as having ownership. And then our oxygen has 1, 2, 3, 4, 5, 6, 7, but it wants 8 out there. Okay, hydrogen is good over here. It has its 2, it has its own, and enough of oxygen spin through it that it feels like it has 2. It shares those. It's good to go. So what happens is another hydrogen with its 1 proton allows its orbital shell to overlap with oxygen's, and oxygen feels like that's its 8th electron out there. So now oxygen's happy, both hydrogens are happy because they're sharing. Hydrogens feel like they have 2 in their outermost shell. Oxygen feels like it has 8 in its outermost shell, even though they're sharing to get that. Okay? Now, this area of sharing, this overlap, okay, that is called a covalent bond. What a covalent bond is, it's a extremely strong chemical bond in which in which electrons are shared. It's exactly what a covalent bond is. Extremely strong chemical bond in which electrons are shared. This is one of the, if not the strongest bond. It's either this or maybe the ionic bonds are the strongest bonds in chemistry, in biology. They're sharing parts. Okay? Now, something interesting happens here because of this. Okay, now I'm going to change ink colors just so you can see what I'm talking about here. Oxygen, remember, has 8 protons in this nucleus. Hydrogen has 1, and then this hydrogen has 1 as well. That oxygen has 8 times the positivity than does the hydrogen. So what does that mean? I drew these as egg-shaped for a reason, these hydrogen orbitals. Oxygen will pull electrons closer to itself because of this positivity here. So this electron spends more time around the oxygen than it does around the hydrogen. Same thing here. This electron spends more time around the oxygen than it does the hydrogen. And the reason why is this positive pull inside of here. Okay? What that does, because this negative electron is spending more time towards the oxygen, so is this one, the oxygen takes on a slightly negative charge. And then the opposite is true as well. Because these electrons spend less time around the hydrogens are getting their negativity pulled away from them a bit, and they take on a slightly positive charge. That is called being polar. Polar means having negative and positive poles or ends to the molecule. Okay, so guys, I'm going to move on. If you need to pause or rewind, obviously go ahead and do that. And this is what we had just said down here at the bottom. So down here now, because oxygen has more protons, it will pull electrons towards itself. That is called, and you don't need to know this, but some of you may want to know. This means that oxygen has a high electronegativity. Okay, it means it's pulling electrons towards itself with these different types of bonds, these covalent bonds, and we know that oxygen is electronegative. Okay, and this makes a water molecule polar. I got to give you the definition of what polar means. Okay, polar is a molecule that has electrical poles. That's where polar comes from. Electrical poles means a positive end and a negative end. A battery is polar. I have a picture here for you. Even like a AA or AAA battery, they have poles too. If you look at the shrink wrap that goes around them, it will tell you which end is positive and which end is negative. Okay, here with the 9-volt battery, you can tell right here, it's telling you which one's negative and positive. Batteries are polar; they have negative and positive ends or poles to them. So is a water molecule, and other molecules are too. Okay, so polar, having those electrical poles, which means you look over the surface of that molecule and you can see positive and negative ends. Nonpolar does not have that. You look over that entire molecule and it is neutral throughout. There is no accumulation of positive or negative on different ends of that molecule. Again, it has nothing to do with polar bears. I just stuck that there. I don't know why. Kind of silly looking. Okay, but polar means positive and negative ends. All right. This is everything we just said written out. Okay, I don't expect you to write things down as I'm saying them. Okay, so this is what I've been saying as we've been kind of going through this. Okay, let me point to this very bottom bullet here. Water is neutral. Now that might be confusing. What I mean by that is that one oxygen has 8 protons and 8 electrons. Okay, each hydrogen has 1 proton, which is positive, and 1 electron, which is negative. So if we add these up, so for water, we have 8 protons from water, 1 from each hydrogen, which means we have 10 positive protons in one water molecule. For electrons, we get 8 from the oxygen. We get 1 from each of those hydrogens, which means we have 10 of these negative electrons. Well, guys, look at this. We have 10 positive particles, 10 negative particles. That's why a water molecule itself is neutral. But the way that those positives and negatives are arranged, we have a negative end, which is where the oxygen is, and a positive end to our water molecule. That's what I mean with these. The oxygen has this negative, and the hydrogens have a positive because of the way those electrons are pulled and distributed. Okay. Now, You could draw this very simply if you would like to, but hydrogen bonds exist between water molecules. So in this picture, here's an oxygen, here's the hydrogens. Here's the oxygen of a nearby water molecule, and then here's some hydrogens. Right here and here, here and here, those are the covalent bonds. Now, people mess this up, guys, on tests and quizzes. Covalent bonds exist within one water molecule. Two covalent bonds hold one water molecule together. When you get water molecules next to each other, this positivity from the hydrogen is attracted, almost like a refrigerator magnet, to the negativity of this nearby oxygen. That is called the hydrogen bond. Okay? Hydrogen bonds exist between different water molecules. Okay, so that's how a hydrogen bond is formed. Hydrogen bonds are extremely weak, but there's usually never just one of them. Okay? Many, many, many hydrogen bonds create strength and can hold molecules together. Okay? So basically we can say here a hydrogen bond. Hey guys, some books may not even call it a bond. They may call it an interaction or an attraction. Okay? We're going to say it's an attraction between, we'll say the negative oxygen of one water molecule and the positive hydrogen of a nearby water molecule. Now, technically, hydrogen bonds can happen between hydrogen, and I haven't looked this up, but if my memory serves me correct from my chemistry classes, it can happen between fluorine, oxygen, or nitrogen. But we're just going to say it just happens between oxygen because that's all I really need you to know this year. Okay, in a chemistry class or in college, if you hear about hydrogen making a hydrogen bond to, I believe it's fluorine or nitrogen, that is absolutely true. But we're just going to refer only to oxygen. That's what we need to talk about here. Okay. Here's just a little animation of, the white hydrogens making a attraction, that hydrogen bond to those red oxygens, okay? All right, now let me just show you some pictures here. Here is what hydrogen bonds look like in our lives. In top left here, you see this water strider, and it is standing on top of the water. It is not wet. It is standing on top of the water because it has such a low mass, and its mass is distributed over, its appendages there, that it's not being pulled through the water. Its mass is less than the force that those hydrogen bonds can generate. Hydrogen bonds are almost like water molecules holding hands with one another. So this insect here, it's almost like it's done like a trust fall, and all the water molecules are holding hands, and it can't fall through. It's resting on the hydrogen bonds. If you look over on the top right, that's a penny with drops of water put on top of it. The drops of water are more attracted to each other through hydrogen bonds than they are to the metal of the penny, and they would rather stick to one another and kind of make this dome shape. Okay, and it's a very similar thing to this glass of water in the lower left-hand picture. The hydrogen bonds allow that water to be poured above the rim of the glass because they'll hang on to each other with those hydrogen bonds. Now, if you put more water on that penny or you poured this glass of water taller, eventually gravity would become the stronger force because you're adding more mass of water there, and gravity overcomes the force of the hydrogen bonds and pulls it down over the side. Okay, but that's where you've seen hydrogen bonds happen. Sometimes you call it surface tension. In class, we'll refer to this as cohesion, but you don't need to write that down. Okay, so I just wanted you guys to stop with the hydrogen bond stuff. Okay. So please watch this video again if you need to. All right, I'm going to show you some more videos. You're going to do some work in class that's going to illustrate this stuff to you. If you do not understand, you need to let me know so I can explain it to you or to the whole class a different way. Okay? All right, guys, and that's about what I needed you to do for this video.